Okay, this is the P2 paper from October 2021. It's question number 6, which, as we can see here, is coordinate geometry. It's the equation of a circle work, circles and triangles. Let's have a look at what we've got. It says we've got the equation of the circle written down like that. Can we find the coordinates of the centre? Yeah, well, what we need to do then is to realise that if we've got the equation of a circle, what we actually want is to have it in this format here. X minus a squared plus y minus b squared equals r squared. And then AB is the centre and r is the radius. So if we look up there, we haven't quite got that how we want it. We want to have it as two completed squares. So that's telling me what to do. So I've got x squared plus 10x plus y squared minus 12y is equal to k here. So what I need to do is to complete the square on the x's and complete the square on the y's. If you're happy with your method for doing it, don't worry about what I'm doing, just get to the same answer as me. The way that I do it is I say, take the 10 and half it, which is 5. So I say plus 5 squared minus 5 squared. I do the same with the y's. I take the minus 12y, I half, that is 6. I'm not worried about the sign of it. So I do plus 6 squared minus 6 squared, and then is equal to k. And the whole point about my one then is that that bit there is already a completed square, and that bit there is already a completed square. So on that, I've got x plus 5 all squared minus 25. And on the other bit, I've got y minus 6 squared. That's why we get the minus 12y. Minus 36 is equal to k. So I end up with x plus 5 squared plus y minus 6 squared is equal to, in this case, k plus 61. If we go back and look at the first part then, the first part says, can I find the coordinates of the centre? Absolutely I can. Centre is minus 5, 6. Part B, it says, state the possible range in values for k. Well, I wouldn't have understood this till I've actually got it to this stage here now. K plus 61, well, k plus 61, if it's equal to r squared, has to be greater than 0. So if that's true, then k has to be greater than minus 61. So that's a nice little question for part B. Part C, what does part C says? Part C says the point P0, the point minus 2, 10, the point 8, minus 14, all lie on different parts, so lie on a different circle, but they all lie on the circle. Given that P is positive, QR is the diameter of C2, can we find the exact value of P? Right, so what I need to do, you remember that I'm going to move down the screen here, but what you've got to do then is, you don't have to, but I think it's much easier if I draw a circle now and try and put on the information that they've just said. So they've said I've got the 3 points, but one of the things that they've said, so I'm going to try and make that happen in my diagram, is that when I'm doing it, they've said that Q and R are actually a diameter. So R is 8 minus 14, Q was minus 2, 10, and then P was the point P comma 0, and P is what I'm trying to find. So now I've got the diagram, this makes this much easier for me to actually try and work out what I'm doing. If QR is the diameter of the circle, then what I can say is that angle P there is going to be equal to 90 degrees because we've got an angle in a semicircle from our IGCSE work. So if I'm going to try and prove that angle P is equal to 90 degrees, what I'm going to do is work out the gradient of that one, work out the gradient of that one, and then show they're perpendicular to each other. The way to show they're perpendicular to each other is to show that one of the gradients is minus 1 over the other one. So let's get ahead and start doing that. So gradient of PR first of all. Gradient is always y2 minus y1 over x2 minus x1. So if I do that for PR, I'm going to get, depending on which way round I do it, I'm going to do this one minus this one. So I'm going to get 0 minus 14 over p minus 8, which is going to give me 14 over p minus 8. If I do gradient of pq, again, y2 minus y1 over x2 minus x1. So that's going to give me, looking at that one, I'm going to do this one, take away this one this time. So I'm going to get 10 minus 0 over minus 2 minus p there. So in other words, 10 over minus 2 minus p. And now we're going to say, so just need to explain this. If p is a right angle, then gradient of PQ is minus 1 over gradient of PR. Or you can say, another way of saying this, if you've got M1 is minus 1 over M2, a better way in this case, and what I'm going to use in this case, is I'm also going to say then that M1 times M2 equals minus 1. I always teach this to my students as an easy way to remember it, but actually in this case, if that's true, I'm going to do that the two of them multiply together to give minus 1. So let's do that. So I've got 14 over p minus 8 multiplied by 10 over minus 2 minus p is going to equal to minus 1. So I've just got to solve this. Is all going to be some sort of quadratic that I'm going to have to tidy up here now. So if I'm going to do that, I'm going to get 140 is equal to, and on the other side, if I multiply that all out, it's going to work out to be, you take your time to do this, but p squared minus 6p minus 16. Okay, and that's these two multiplied together and multiplied by the minus 1 up there. Take your time to do that. So this all tidies up to p squared minus 6p minus 156 is equal to 0. You'd hope that factorizes, but it doesn't, only because I've done this question already. So in that case, I've got to put it into the quadratic formula. So p is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Stick all our values in, so 6 plus or minus the square root of 6 squared, which is 36, minus 4ac, so it's minus 4 times minus 156 all over 2. If we tidy that up, that works out to be 3 plus or minus root 165. You just take your time to do that. And then going back to the original question, it told me that p was a positive constant. So as I'm going through and do this, p is going to be 3 plus root 165 as the final answer. Okay, hopefully that all makes sense.